Hello everyone and welcome to another part of the Galaga SDL tutorial videos. And in this video we're going to finally start working on some gameplay. So we'll create the player and set up all the logic for his movement on screen. So the first thing we're going to do is create the player.h. So let's create a new item, player.h, and then do if not defined underscore player underscore h. Define underscore player underscore h, and then end f. Now there are two classes that we're going to need here. The first one is gonna be our animated texture. Even though we're not going to be using an animated texture in this video, we will need it for the player's death animation, and it also includes the texture.h. So instead of just including texture.h now and then animated texture later, we'll just add it now. And then we will also include the input manager.h. Now moving on to the class itself. So class player, and this class will inherit from game entity. So public game entity. And right now it doesn't know where game entity is because we're not using namespace quick SDL, and there we go. So this should be it for declaring the class. Now we can go ahead and create our private variables. So for private, we will need the timer and the input manager. So a timer pointer, timer, and an input manager pointer, input. Then next up we'll do a boolean visible, and this visible, and this will be true if the player is visible on screen. So we'll use this to switch the player on and off. And we will also need boolean animating, and we'll use this one to stop the player from moving if they're being killed, or if we have the ship capture animation going, and so on. So we'll have animating for that, and then we'll have int score and int lives, and this is the current score, the score of the current player that we have, and the lives remaining of the player. And next up we'll have our texture pointer, and this one will be called ship, and this will be just the player's ship. Okay, so finally the last two variables that we need for now, which are the movement speed and the move bounds. So float move speed, and then this should be pretty self-explanatory, and then a vector2 move bounds. And move bounds will be the minimum x and the maximum x that the player can translate between, because he can't really access the whole screen because of the sidebar of the play screen. So we need to constrain it to these two values. And that should be it for the private variables. Next up is one private function that we need. So private void handle movement, and this will take care of all the movement handling for us. And then public, and for our publics we will have the constructor and destructor. So player and player. And then we will have a few variables to, for example, set the visible to true or false. So void visible, which will take a boolean visible. We will also have a void is animating, and we will use that later to find out whether or not the player is done animating or not. So we'll have that. This is because we might want to wait for the player to stop animating until we recover the player so that he has the ship again, so we can start moving after death, or we can start him moving again after he captures the ship, and so on. So that should be fine. And then int score, which will be the getter for our score, and int lives, which is the getter for our lives. Next up, we will have avoid add score, and this will take an int change. So this function will be adding score to our mScore variable. And then void update and render. So void update and void render. And that should be it for all the variables and functions that we'll need for now. So now that we have those, we can move on to creating our player.cpp. So Galaga, add new cpp player, and then include player.h. And the first thing that we're going to create is our destructor in here. So player. So let's start off by our variables, which are at the top. So timer and input. So let's get the instances for those. mTimer is going to be equal to a timer instance. And minput is going to be equal to the input manager instance. Now visible, we'll set visible to be false at the beginning, because the player starts off being invisible on the screen until stage 1 starts. So that should be fine. And then animating is false to start off. Next up we have score and lives. So we'll have mScore is going to be equal to 0, and mLives is gonna be equal to 2. Now next up we will have mShip is going to be equal to, and we already have a ship texture that we're using for I wonder where it went. Oh, there we go. Well, we have the ship texture that we're already using for the lives on the sidebar, so we'll be reusing the same texture, which is called playership.png. So new texture, playership.png. There we go. And then we will set the parent of mShip to be the player. So mShip parent is this, and mShip position is going to be centered onto the player, so it's going to be vector to 0. So what we still need now is our move speed and movement bounds. So we'll say that our move speed is going to start off, let's say something like 100 in 0f, and move bounds is going to be equal to a vector 2 of 0.0f, and let's say something like 800.0f. So this is our lower bound and this is our upper bound for that. So the player is going to be moving between 0 on the screen on the X and up to 800, because I believe our Windows width is 1024. And then we'll edit this value so that he matches the inner bounds of the play screen or the play area. Okay, so this should be it for our constructor. For our destructor, let's clear some of the memory that we allocated. So we'll do player. First we need to set the timer and the input to null. So mTimer is equal to null, and minput is equal to null. We will delete mShip and set mShip to null. And that should be it for our input, our player destructor. The next thing that we're going to be working on are, well, we'll leave the handle movement for now. So let's create some of these functions. So visible, it just sets the invisible variable, so we can do that. Void player visible. We'll take a boolean visible, and we'll say that invisible is going to be equal to visible. So that should be it for that function. Next up is our isAnimating, and isAnimating will just return animating. So So boolean player is animating. In here it will return M animating. Oh, this is a void for some reason. Nope, is animating should be a boolean. Okay, so that should be it for that. Alright, next up is the score and lives, and this will just return M score and M lives. So int player score return M score, int player lives will be return M lives. Okay, and then next up is our add score, and add score will just increment score by the change amount in our void player add score. This will take in an int change, and then we'll say M score plus equals the change. So that should be it for those functions. So what we're missing now is the handle movement, update, and render. What we can do is just declare the handle movement up here, right up underneath the constructor. So void player handle movement, and we'll leave it empty for now because this is going to be the biggest function in our class in this video. So we'll implement it later on. For now, let's go down here and implement our update and render functions. So we can do void player update, and in our update we want to only handle the player's movement if he is not animating. So first off, we need to check if the player is animating or not. So if M animating, we will do nothing for now, else we need to check whether the player is active or not. And active will be the same as visible in render. Active will act as the same idea in our update. And active is a part of the game entity class, so we have that already set for us. So we can say if active, and we need to call the function, not the variable, because the variable is a private in our game entity class. We just need to access it through the function. So we'll say if this object is active, we can say handle movement. And now we can move on to our render function. So void player render, and we can follow the same way of thinking here. So we need to check if the player is supposed to be visible or not. So if M visible, we can draw whatever we have. So first we need to check whether the player is animating or not. So if M animating, we will be rendering the animated textures. Otherwise, we will be rendering the player's ship. So we can say over here, M ship render. And this will be it for our player's render. So the only thing missing now is our handle movement function. And for this function, we will have we will check whether the right or left arrow keys are pressed, and if they are, we need to translate. So what we can do is say if M input or key down. So as long as the key is down, SDL underscore scan code underscore right translate, and the translation will be onto the right side. So we'll say vec2 underscore right multiplied by our move speed, M move speed, multiplied by our M timer delta time. And that will be it for our right movement. The left movement will be the same idea, else if our M input key down is SDL underscore scan code underscore left. We need to translate to the left. So translate negative vector, right? Multiplied by m move speed multiplied by m time timer delta time. And that will be it for translations, but you'll notice that this is given an error now, and this is because we didn't overload the negative operator to flip a vector's direction. For that, we will go back to our framework, so math helper, and inside math helper, right underneath, so inside the struct still, underneath the minus equals operator overload, we can overload the negative operator as well. So we can do vector2 operator minus and two brackets const, and we just need to return the flipped version of our vector. For that, we will just do return a vector2, and this will be our negative x and negative y. And this will be it for our negative operator overloading. Now if we go back to player.cpp, it should know what negative vector is, and we can move on. Okay, so the last thing that we need to do after translation is to check the bounds. For this we will create a vector2. So vector2, we'll call it position, which will be equal to our local position, so position local. And then say that if position.x is less than the minimum of the bounds, so m move bounds.x, the position.x is going to be equal to the move bounds.x. And then else if the position.x is more than m move bounds.x, then the position.x is going to be equal to the move bounds. Or if the position.x is more than the move bounds.y, so the upper bound, we need to set the x to be as high as the upper bound, so move bounds.y. So if it's less than the move bound.x, it's equal to the move bound.x. If it's more than the move bound.y, it's equal to the move bound.y. And then after we do the bounding, we just need to reassign it. So position, position. And that should be it for this part. And this should be it for the player class for this video. So now we can move on to the next class that we need to edit. And this one will be our play screen. So in our play screen.h, we can now include player.h. Actually, we will also need the player.h in a level. So for that, we will just go to the level and include player.h, and that should include it in our play screen. So we can just keep it at that. Actually, the level contains the background stars as well, so we probably don't need it here. And it includes the play sidebar as well, so we probably don't need it here either. So input manager and level, and then the player includes the input manager, so we don't even need the input manager here either. So that should be it for that. Now down here we need to create a new player in the play screen, because a level cannot have a player instance every time. We need to pass it in the player instance so that the player can be moved from one level to the next. So over here we can, all the way at the bottom, we can say player pointer and player. And in playscreen.cpp, we can create that player. And for creating the player, we need to set it to null in the constructor, because we don't need a player yet until a new game starts. So start new game should be creating the new player. So over here we can say player equals null. or mPlayer. mPlayer equals null. Then down here we can delete mPlayer in the destructor and say mPlayer equals null. Okay, so what we need to do now is to set our start new game. So our start new game will delete the old player that it had. It will create a new player and set all its parameters. So we can say that we need to delete mPlayer, and then mPlayer is going to be equal to a new player. Now the player's position, so player parent, we can set as this. The player's position is gonna start off being in the middle. We want it right in the middle of the play area. And for this, we can put it where our start label is. So let's put it there. We have our start label's position, and we can just copy what we have there into it. And we know that 0.4 will be in the middle of our X on the play area. But for the Y, this is going to be too far up. So let's move it to something like 0.8 instead. And that will be it for this part. So the player is being created, and this is where it's being positioned onto the screen. The last thing that we need to do is set it to inactive so that the player cannot start moving before the level allows it to. So we can say mPlayer active to false. And that will be it for the player itself. Now we can actually start using the lives so that we can start using these two in the sidebar instead. So we can say mPlayer, so for the set ships, we can say mPlayer lives, and that will give us the two that we need. mSidebar set player score to mPlayer score. Because the player starts off being 0, this will set our player score to 0 as well. And then the current stage, let's set it to 0 for now. So that should be fine. Okay, and that should be it for the changes that we need in here. The last thing that we need to do is to update this player and render it. For that, we will need to go down here, and over here we have our, if the game started and the level started, we're updating the sidebar and the level. We need to change that a little bit. We need to remove the level started, and we'll say that if mCurrent level, or the current stage, is more than 0. So as long as the current stage is more than 0, we want to keep updating the sidebar. That keeps the player, the 1UP label, blinking. So we have that going. Now if the level started, we need to update the level. So if mLevel started, we need to update the level. So that should be it for these two. Next up, we need to update the player. So mPlayer update. And that should be it for that. Now for the rendering. So what we have in the rendering right now is we're rendering the sidebar. If the game hasn't started, we are showing the start label. And then if the game has started, we're updating the level. Now we need to change that a little bit as well. So we can remove if m started, and then we can have just if the game has started. For the level, we can say if mLevel started, update the level. So that should be fine. And then mPlayer update. And this will be it for our changes that we need for the play screen. So we have the player now created, it's being updated and rendered. So the last thing that we need to do is set its visible and active to true inside our level. For that, we need to give each level that we create access to the player. So if we go to level.h, in the level constructor, we can pass it a player pointer as well. and we'll call this one player. Now, we can go back to our level.cpp, and we need to update our constructor to make use of that. So we will have player pointer player, and now that we have this here, we can make a player variable. So in our level.h, all the way at the bottom of the variable, we can say player pointer and player, and then assign this in our constructor. So we can go here, and somewhere over here, let's say, or actually maybe at the bottom, we can say mPlayer is going to be equal to player. And then in the destructor, we'll set it to null, because we're not creating it here, so we don't need to destroy it here. So we'll just say mPlayer is equal to null. Okay, so what we need to do now is to set the player to active as soon as the player should be active. And the player should be active when the ready label goes off screen. So the player should be able to move, and he should be able to, when he should also be visible as soon as the ready label is off screen. So we'll add 2 brackets here for this if statement and say that we're starting the stage. We also want the player to be active. So player active to true, and the player visible to true. And this should pretty much be it for the player. So let's go ahead and test it out and see how it goes. So let's run this and see if we caused any errors. Yes, we did. Okay, so level. Function right. So in here now, in the play screen.cpp start next level, we need to pass it in the player that we just created in the start new game. So it will take in player as well. Now, what else do we have here? Right, in the player's handle of movement, missed a semicolon here. And that should be it for that. So let's see how it goes now. So enter. Wow, that was pretty loud. So ready, and then the player is not there. Okay, so let's see what we've missed. If we go back to our play screen and let's see if the player is being rendered, he should be rendered here because the player is the game started should be true by this point, so that should be fine. In our level, the stage is being started, so it should be visible. So the only thing left is to check visible. So if we go here, so ship render, we can go right here and see what's going on. All right, so it's not coming in here. And it's not going in here either. So the player render is not being called actually. So in our level or in our play screen, for some reason I have update twice. Okay, so in our render, we'll call the player render, and that should fix the problem, hopefully. Not sure why I did that. Okay, so for our debug, delete all breakpoints, yes, and let's run it again and see what happens. So stage 1, ready, and then once ready disappears, the player's on the screen. If I press the left side, he moves to the left very slowly, so we need to fix that, and he stops here, so we need to fix that as well. And we need to figure out what the bounds are. Okay, so for the bounds, first let's fix up the player movement. So in player.cpp, we want the player to move faster, so we'll come here and change this one to maybe 3 times as fast, so maybe 300, and then see how fast this will be. There we go. So this seems to be pretty good. Now we need to check the bounds. So we'll come over here, let's say somewhere around here, and then put a breakpoint here. Once we have it there, we'll check this game entity, and our position is, let's say, 40 or so. So we'll stop the player, we'll set the lower bound to 40. So we'll go back up here in our move bounds and set that to 40. And then let's try the upper bounds. So for the upper bounds, we'll go over, and let's say somewhere around here is good. And let's see where that is. So this one is at, we have our game entity, and this one is at 716 or 718. So 717. So let's say 720. So 720. And that should be it for that. Let's remove the breakpoint again and try this one more time. There we go. So he's stopping here, which is good. And here is good as well. So we have our play area and we have the player moving. The player is a bit too high, so we need to lower him down a bit, and that should be it for the player movement. So we can go now back to our play screen where we're setting the player's position. And instead of 0.8, we'll set it to something like 0.9. And let's see what that looks like. Okay, so this looks pretty good. We have him now moving and he's in the right area. So that should be it for the player movement. The last thing that we can do is to check whether the player is allowed to move between levels or not. So we can go to our playscreen.cpp, and in the update right under the player here, we can say if input key pressed SDL underscore scan code underscore N, let's say, M level started equals false. And what this will do is set it back to false so that we can start the next level, so that it can delete the old level and start our new level. And we'll check whether the player holds in between these levels or not. So there we go. So that's our stage 1. And we can move the player around. We can press N. There is stage 2. So we can still move and the stages are being incremented. So now we have everything set up so that we can do the player firing and adding the enemies. We'll leave collision all the way at the end. So we'll add the functionality for the player dying, the player firing, and everything there, and the player and the enemy death there and everything. But we will do the collision all the way at the end. But everything seems to be working here. And this will be it for this video. So I really hope that this video helped. If you have any questions, suggestions, or feedback, please leave them below. Otherwise, thank you very much for watching, and I will see you in the next video.